This video is going to go over solving absolute value inequalities either algebraically or graphically. So let's go ahead and get started. We'll do graphically first on these, and then we'll do algebraically. So graphically, just be able to graph like this line as is, so absolute value of x plus 3 plus 1. Find your vertex, put a dot there. The slope of this absolute value is 1, so just go like this. You want to try to be as accurate as possible if you're going to do these graphically. Okay, so that's the red part of it. Now, this other section here, 4, graph it as if it said y equals 4. So just find 4 on your y and draw a horizontal line there. Now you're going to identify where these spots kind of crisscross. And then what you do is you have to be able to read an inequality. So this symbol right here is greater than. So it's like it's saying, where is this red line greater than that blue line? So the red line becomes greater than the blue line here and here. So the way you answer this is you say, okay, that spot it hit was an x value of -6, and then it was everything to the left of that. So all my x's that are less than -6. And then over here, it hits a value of 0. Right here is 0. And it's everything to the right of that. So that's going to be all my x's that are greater than 0. And when it's like this, with like 1 going to the left, 1 going to the right, usually they want you to put the word or in between them. So like that would be my answer. All right, let's go ahead and look at it algebraically. First of all, you gotta get the bars by themselves. So go ahead and subtract 1. So now you're at x plus 3 in the absolute value bars is greater than 3. Okay, if it said equals here instead of this greater than, you would write it twice, right? Once as normal, once times -1. Well, you're still going to kind of do that. So go ahead and start writing it twice. It should look like x plus 3 greater than 3. That's my as is. And then once times -1. So x plus 3. Now right here, when you times by -1 on an inequality, the sign switches. So it's going to switch from this greater than to a less than symbol. And then we times the 3 by -1, so now it's -3. Now you just go solve these. So over here, -3. So that's everything x, keep your symbol like this, greater than, just like before, greater than 0. And then over here, -3, -3. So that's going to be x less than -6. And so if you get like, if you think about like a number line, greater than 0 goes this way, less than -6 goes this way. If they go in opposite directions, that's when you need the word or. So you kind of have to think about it after you solve. This one would need the word or in between there, like that. And your answers should match graphically and algebraically. It shouldn't matter how you do it. You should get the same answer. Okay, this next one is a bit more challenging on the graphing portion of it. So I'm going to find my HK first. So the HK here is at 2, -3. So 2, -3, put a dot there. Now the slope of this absolute value is 2. So I'm going to rise 2, run 1 either direction, like that. Okay, so this is what this line looks like. All right, now the second one, this is like it says y equals 1. So just go find 1 on your y and draw a flat horizontal line there. Find out where they crisscross. So here and here. And now think about what they're asking you for here. They're saying everything that is greater than 1. So all of this red line that is above the blue line. So this is similar to the one we just had. So it would be everything from 0 this direction to the left, and it would be everything from 4 this direction to the right. So everything that's less than 0 or everything that's greater than 4, like that. Now, algebraically, this one's going to be a bit more challenging than the last one. You would add 3 first. You would divide by 2. Okay, now the bars are by themselves, so I can write it twice, once as is, once times -1. And remember that 1 times -1, it flips that inequality, so your symbol's a less than now. Solve each one, add 2. This one I get x is greater than 4, add 2. This one I get x is less than 0. So they're going opposite directions here, less than 0, greater than 4, so you need the word or, like that. Okay, this next one, go ahead and graph it. So find your vertex of 0, 2. Put a dot there. Slope of this one is 1. Okay, graph the other line. It's like it says y equals 4, which is here. Find out where they crisscross. Now it wants everything greater than or equal to 4. So everything that is above that blue line, that would be this section and this section. So that's all these x's that are -2 going to the left or +2 going to the right. So all my x's that are less than -2 or all my x's that are greater than +2. Now, wait on this one. You're not done yet, because if you look at your original inequality, it's an or equal to sign. If that happens, you need or equal to signs in your answer, like that. So before we didn't have that, like here before we didn't have it because the inequality did not have it. All right, now algebraically, you would subtract 2 first. And so you're looking at absolute value of x is greater than or equal to 2. So you write 1 as is, x is greater than or equal to 2. And then you times by -1, so the sign switches, x less than or equal to -2. And if they're going opposite directions, you need the word or in there, like that. Okay, next up, go ahead and graph this absolute value of x minus 3. So your vertex is at 3, 0. Go put a dot there. It has a slope of 1. Okay. Now graph your second line. It's like it says y equals 4. So find 4 on your y and draw a horizontal line there. Find out where they crisscross. That's here and here. Okay, now this one's a little different because they want everything that's less than or equal to 4. So that's everything below the blue line. That would be all of this section in black here. Now, when this happens, when it's just like they're not going opposite directions, you know, like before, these answers were going opposite directions. When they're going towards each other, you just write it like this. it's -1 here, all the way to 7 here. -1 to 7. So it's everything that is, you can write it as one inequality. You write the little number on the left, so -1, and then the big number on the right, 7. And the way this reads is -1 is less than x, which is less than or equal to 7. So when they're going towards each other, you can write it as one inequality. When they're going away from each other, you write it as two inequalities with the word or. Okay, now solving this. The bars are already by themselves, so I'm going to go ahead and just write it twice. Once normal, and once times -1, which flips this inequality like that. Solve each one by adding 3. So I get x is less than or equal to 7. X is greater than or equal to -1. So when you get here, you kind of have to think about it. Are these going towards each other or away from each other? These are going towards each other. So -1 less than or equal to x less than or equal to 7. Remember, it goes little number on the left, big number on the right. That's only when they're going towards each other. Go ahead and graph it. So find your vertex, -3, 4. Put a dot there. Now your slope is 1/2, so rise 1, run 2. So it looks something like this. All right, now graph the other one. It's like it says y equals 5. So find 5 and draw a horizontal line. Find out where it crisscrosses. All right, so now think about it. They're saying everything that's less than 5. So that's everything below that blue line. So it's this section here in black. So from -6 to -1. So -6 less than x less than -1, like that. And again, I wrote it as one inequality because these things were going towards each other, not away from each other. And also a quick recap, always match whatever inequality symbol they gave you. So like on the previous one, they gave me an or equal to. So in my answer, I had or equal to's. Okay, now let's go ahead and solve this last one algebraically. You would subtract 4. You would divide by 1/2 or times by 2/1. Same thing. I'm going to times by 2/1. Now that the bars are by themselves, I could write it twice, once as is, once times -1, which flips my inequality. Solve each one. So I got x is less than -1, x is greater than, I think we messed up somewhere on the graphing. Sorry, because when we did it algebraically, we got -5, greater than -5. So I think this is an example of why you have to be perfect when you graph these lines, because over here, we had our vertex here. We rise 1, run 2, rise 1, run 2. So I was off just a little bit when I graphed it, and it gave me the wrong answer because of it. So this is why you have to be exact. So it actually hit here at -5, not this spot at -6. So in my answer, it'd be a -5 here. Sorry about that. But that's a good example of why you try to be really accurate when you graph it. All right, now in terms of this answer here, I would notice that Greater than -5, less than -1, that's going towards each other. So I can write it as one inequality with the little number on the left and the big number on the right, like that. So hope this video helped. That is how you solve absolute value inequalities, both graphically and algebraically. Good luck.